In the problem number 16, a cylindrical metallic rod in contact with two reservoirs of different temperature at its two ends conduct an amount of heat Q in time t. Now the metallic rod is melted and material is formed into a rod of radius half of initial radius. Means if I consider final radius by r dash, then that is r by 2. Okay. Then amount of heat conducted by new rod when placed in thermal contact with the reservoir, same situation in time 2t is. As per the question, first I am going to use the formula of heat current. So you know initially that is Q, coefficient of thermal conductivity, area of cross section, temperature difference divided by the length into time, and this is my equation number 1. If I go the situation number 2, according to the problem we'll write K, because radius becomes half and length becomes 4 times, so we'll write K A by 4. A by 4, but why? Because radius is going to change by R by 2 into temperature difference and time according to the problem 2T divided by the 4L, and this is my equation number 2. Easily you can divide equation 2 by 1. Then K, delta, theta, T and L will cancel out. So you have Q dash upon Q, that is 1 upon 8. So that will give you the amount of heat Q dash Q by 8. So this is how you can calculate. So my option number 3rd will be the right choice. Let's move on. Question number 17. In the problem number 17, an ideal monoatomic gas follow a law P directly proportional to T square. In addition to ideal gas law, good, then molar heat capacity for the process is. We know in the case of polytropic process, if I am looking to find molar heat capacity, then it will calculate by Cv plus R upon 1 minus N. So I need only two things. One is Cv, and you know Cv is calculated by 1 by 2 into Fr. F means degree of freedom. So nature of gas is monoatomic. So value of Cv will be 3 by 2R, because degree of freedom for monoatomic will be 3. And second requirement is N. So we'll see. Because P is proportional to T square. T means temperature. And if I use the ideal gas equation PV equal nRT, because I am looking to find the value of P in terms of B. But why? Because in the polytropic process, PV power n is equal to constant, where n is the number and n gamma की वैल्यू के इक्वल नहीं होगा, बिकॉज सिमिलर फॉर्मूला एडियाबेटिक प्रोसेस के लिए भी होता है. तो n का वैल्यू जब गामा की वैल्यू के साथ जस्टिफाई नहीं करता, तो उस टाइप से PV इक्वल n, फॉर योर सिंप्लिसिटी यू कैन कंसीडर दिस इज ए नंबर. तो आई एम लुकिंग टू मेक दिस टाइप ऑफ रिलेशन. So I want to replace the value of temperature in terms of pressure and volume. So we'll write here P proportional to PV pi nR with square. So that will give you P proportional P square V square. Square of P will cancel. So I can write PV square equal constant. So if I compare with PV power n is equal to constant, then you will get value of n will be 2. So this is how you can calculate the value of n. When I will place all values in this expression, C is equal to 3 by 2R plus R upon 1 minus n. N means 2. So when you will calculate, you will get R by 2. So this is the value of molar heat capacity. So my option number 2 will be the right choice. Let's move on. Question number 18. In the question number 18, 5 moles of diatomic gas is taken through reversible cycle ABCDA according to diagram. The thermodynamic efficiency of cycle is nearly. First I would like to say, if you are looking to find the value of efficiency, you need two things: work upon input. Any kind of efficiency you can calculate by taking output to the input. So this is a general phenomena, but this question is very important for the NEET. So we'll see. First, if I go for this cycle, I am looking to find the work done A, B, C, D. So you can see Area under PV graph, you know very well. So if I go for pressure 2P naught and P naught, so we'll write 2P naught minus P naught. In the case of volume, 2V naught minus V naught. So you will get P naught V naught only. And this is my relation number 1. Second, if I concentrate the process AB, A to B, then you can observe volume will remain constant. If volume will remain constant, then we can use P1 upon P2 and T1 upon T2. Okay, so if I consider the temperature at A is T naught, so in the process A to B, I can write P naught upon 2P naught, temperature as I said T naught, and at the point B, I am looking to find the temperature at B. So this expression will give you the temperature at B, and that will be 2 times of T naught. This is my relation number 2. Similarly, if I go for the process BC, in the BC process, you can observe pressure will remain constant. So when pressure will remain constant, I can use V1 upon V2 and T1 upon T2 by the ideal gas equation. So at B, volume is V naught and 2V naught, temperature will be 2, as I said, 2 times of T naught and divide by Tc, because I am looking B to C. B is the beginning and C is the ending. So that will give you the temperature at C, and that is 4 times of T naught. This is my relation number 3. Now I am going to calculate the input amount of heat. So when you will go there, first you will write input. So I will use heat from A to B and heat from B to C. But you have to be very careful. AB means at constant volume, BC means at constant pressure. So you know amount of heat at constant volume mu Cp dt, at pressure P mu Cp dt. So you need to calculate two values. Number 1 mu कितना होगा, number 2 Cb और Cp का value कितना होगा, and temperature difference कितना होगा. And we know that. So first I am going to write the value of QAB, and that will be 5 because number of moles are 5, and 5 are by 2 the value of Cb. Temperature difference, you know A to B because at B 2T naught, so you will write 2T naught minus T naught. Similarly, when I will move from BC, in the same manner as I discussed, we'll write 7R by 2, temperature difference 4T naught minus 2T naught. So when you will add these two values, by solving you will get 5 times of 19 by 2 RT naught, and this is my relation number 4. Now I have the value of input and I have the value of work done. So when I will go the efficiency in terms of percentage, first we'll write work and input amount of heat. And you know, by this diagram easily you can write the value of work will be 5 times of R naught T naught divided by 5 into 19 by 2 R naught T naught. When you will solve this expression, so you will write the final answer just like this, because you know work is equal to 5 times R naught T naught, so you can cancel. So on solving you will get the value of efficiency 10.5%. So in terms of percentage you keep in mind आप 100 से multiply भी करोगे तो 10.5% will come. So this is how you can calculate. So my option number 3rd will be the right choice. So let's move on. Question number 19. At 27 degree, the ratio of the density to the pressure of a fixed mass of an ideal gas is X. At 220 degrees centigrade, the same ratio is. So we know, if I write the ideal gas equation, P is equal to, you know, mu RT by PV is equal to mu RT. So I can write density upon mass into RT, because density is equal to mass upon volume. Because the original equation, you know, PV is equal to RT. If I take number of moles is 1, so I'm going to make a change in volume in terms of density and mass. And another thing, if I write the ratio between density to the pressure and temperature T, and that is equal to m by r, and this is constant. Why I am going to make a ratio between density and pressure? As per the demand of the question. Next, question में दिया जा रहा है, you have the value ratio between density to the pressure is x, right? So that implies that if I replace this value by x, so we'll get x into t will be constant. So now I will use this relation. First I will write x into t, because temperature in the beginning is 27. So when you will convert into absolute temperature, you will write 300. And second one, if I denote by x dash, into, when you will add 220 plus 273, you will get 493. So by this expression, easily I can find the value of x dash, and that will be 300 upon 493x. So that will give you the final value. So my option number third will be the right choice. So let's move on question number 20. In the question number 20, a simple pendulum of length L is suspended from ceiling of an accelerating trolley as shown in diagram. The time period of oscillation of pendulum is equal to. So in this type of question, first you will see this diagram because you know the concept of pseudo force. So this acceleration on the left hand side will be g by 2, and here it is g, and this is the tension. Why I am doing this? Because you know in the case of simple pendulum, the formula is 2 pi root L by g, and we are looking to find the value of effective g. So by this diagram, because you are saying angle between these two is 90, so if I solve the effective acceleration, you will write effective acceleration, because angle between these two is 90, g square, and another one is g by 2 with the whole square. So that will give you root 5 times of 2 into g. During exam, you have to be very careful regarding your time saving. So t is equal to 2 pi L, and you will write the value g effective, and that is root 5g, and by 2 will be here. So very quickly you can get your answer. So my option number third will be the right choice. Let's move on question number 21.